Welcome to today's video where we are going to learn an awesome method called the Gauss Elimination method. It's super cool because it helps us solve the system of equations which can look tricky but are actually pretty simple. So what exactly is the Gauss Elimination method? Well, it's basically a step-by-step process that helps us solve system of linear equations. You know, those equations having the x, y's and z's. The cool thing about the Gauss elimination method is that it's like a set of rules we follow to make the equations simpler. We start with our equations written in a special way called the augmented matrix, which is just a fancy term for the table of numbers. So let me break it down for you. Initially, we write down all our equations in a matrix form. This is known as augmented matrix. Don't worry, it's not as complicated as it sounds. It's like putting all our information neatly in a table. Next, we have to make this matrix easier. So, we use some simple rules to make the numbers in our matrix easier to work with. So, we have to transform the augmented matrix into an upper triangular form. That just means we want zeros below the main diagonal. Once our matrix is in the upper triangular form, we can solve our equations super easily. We just start from the bottom and work our way up, figuring out the values of our variables one by one. To make the things crystal clear, let's solve a real example together. We'll take a system of equations, apply the Gauss elimination method, and see how it all comes together. Here we have three equations which we will solve using the Gauss elimination method. In the step 1, we have to make the augmented matrix for the given equations. This is known as the augmented matrix. Next, we have to apply some row operations to convert this augmented matrix into upper triangular form. So let's now apply the row operations on it. After applying row operations on R2 and R3, that means row number 2 and row number 3. As you can see, we have obtained two zeros here in the first column. Next, we have to make this element as 0 so as to convert it into the upper triangular matrix. So this is our upper triangular matrix where the elements below the principal diagonal are 0. Next, we will solve this upper triangular matrix using the backward substitution. Initially, we will solve the last row of the matrix to find the value of z. Next, we will put this value of z in the equation of the matrix from the row number 2, which is 4 minus 5z is equal to 0. Solving this, we'll get y is equal to 10 by 11. Similarly, solving for x, we'll get its value as x is equal to 35 by 22. And that's it. I hope this video helped you understand the Gauss elimination method. Thanks for watching. Don't forget to like, subscribe, and hit that bell icon to stay updated. Happy solving!